Hi, I'm Shubha, and I'm here with Spencer to talk about Spring Cloud and Istio. So a little bit about us. I work as a product manager with the Cloud Foundry routing team. And in the last 8 to 9 months, in the Cloud Foundry routing world, we've worked extensively on evaluating and trying to use Istio as the routing control plane for Cloud Foundry.
My name's Spencer Gibb, co-founder, co-lead of Spring Cloud for the last four years or so since I've joined Pivotal, and I've been 100% working on Spring Cloud since then. And here's our standard corporate speak.
Yeah, and I'm going to leave this on for 3 seconds to see how fast you guys can read it. No. So as far as the agenda for today is concerned, I'm hoping if you're here, 1, you use Spring Cloud, and 2, you've heard about Istio, or you've gotten your hands dirty and you're curious about how these two frameworks work together, how do they compare, what does this mean for my stack? And we're hoping to answer some of those questions during our talk. So we'll talk about what are the problems that frameworks like Spring Cloud and Istio are trying to solve. And then we'll talk about how these two frameworks solve these problems at different levels of abstraction in the stack. We intend to walk through a few examples to give you very concrete examples of how you might do something in Spring Cloud versus how you might do that in Istio. And then towards the end, we'll talk about, well, should I be using Istio or Spring Cloud or both? What does this mean for my stack? So to start with, to talk about the problems that frameworks like Istio and Spring Cloud are trying to solve, we need to talk about this move in technology from monoliths to microservices, wherein you break one large application into a set of loosely coupled services that might be designed around business capabilities. Each of these services defines standard interfaces and interacts with each other over standard network protocols like HTTP. So microservices have a lot of strengths, and they've gained a lot of popularity because of these strengths. They help teams move faster, they help teams be more independent, deploying their applications, but they also have their own set of problems, most notably the problems of distributed systems. Distributed systems are hard. So as soon as you enter the world of microservices, you have to deal with the problems of distributed systems, and your application developers and your applications become susceptible to the vagaries of the network. You need to take care of network blips and network partitions and latency over the network, security over the network, and so on. And this adds a lot of overhead to application development. So initially, application developers dealt with these problems in a bespoke way in their applications. But over time, certain best practices and patterns emerged, such as circuit breaking, retries, and so on. And this is where frameworks like Spring Cloud came into the picture.
I really liked how Ansi said this morning that Pivotal, one of the strengths of Pivotal is curating the best of breed open source. So at the time, when we started Spring Cloud, we took the best of breed software from companies like Netflix and HashiCorp, as well as popular foundation projects like Zookeeper, and made them easy for application developers to use, right? To eliminate this boilerplate that normally you would have to deal with when building a distributed system.
Right. And Istio, we are now in 2018, and Kubernetes emerged as a fairly popular container orchestration solution. And Istio was designed to provide these common set of services for applications on Kubernetes. It's meant to be a platform to connect, secure, manage, and observe microservices. It's open source. Google and IBM are two of the largest contributors, but there are several others. It's designed to be platform agnostic. In the Cloud Foundry world, we found that a lot of the constructs it uses are very close to K8s, but the community is quite open towards keeping it platform agnostic and making the design decisions to enable that. It supports polyglot services, and I'll go into how it does that by looking at the Istio architecture. So Istio implements an architecture called a service mesh. Typical service mesh architectures have a proxy that runs in a sidecar mode alongside each of your service instances. In the case of Istio, it is the Envoy proxy, which was developed at Lyft and has been used in production for over 2 years, so it's been tested and proven at scale. Now, it is this proxy that is really the secret sauce of the service mesh architecture that provides a host of services to the applications. So it provides everything from service discovery to load balancing to retries, timeouts, implementing popular patterns such as circuit breaking, security, telemetry, policies, and so on. Istio also has a configurable control plane, which helps configure the proxy. And you can see here that Pilot, Mixer, and Citadel help configure different things in the proxy. So Pilot does config data and does a lot of the routing and traffic management configuration for Envoy. Mixer helps with policy checks and telemetry, and Citadel does TLS settings and TLS certificate rotation. So what you can see is that it abstracts away this whole set of patterns from application developers and makes it configurable through the control plane and the proxies.
So Istio and Spring Cloud in general have taken different approaches just from their very natures. Spring by nature is a library and can move very fast, and it can evolve much quicker than the platform can. So they come at the same problems from different points of view. And yes.
Yeah, so they try and solve the same problem of improving application developer productivity from different parts of the stack.
So the first abstraction that you generally need to deal with in a distributed system is that of a service registry and service discovery. Something needs to know about all the instances of all your services, right? And that registration can happen implicitly on a platform such as Cloud Foundry or Istio, Kubernetes, for example, or it can happen programmatically via something like Eureka or Ribbon, or Console, excuse me. And then once those instances are registered in service discovery, then it's up to the application needs to communicate with other services. So how does it do that? It needs to find an instance that it needs to talk to. Again, this can happen via platform with Envoy in Istio, for example. It could be the Go router in Cloud Foundry, or it can be a library like Ribbon from Eureka.
So before I jump into the next set of examples, I just wanted to set these two terminologies because these are terminologies used by Istio and not everybody might not be familiar with them. So I just want to define them. Well, a virtual service, I view it as a route rule. These are typically applied through a declarative syntax expressed through YAML, and I'll go into examples of it. And it's basically configured through Pilot and is propagated to the proxies. So a virtual service defines the rules that control how a request for a service is routed within Istio service mesh, and a destination rule configures a set of policies to be applied to a request once a virtual service routing has occurred. The interesting part that I find here is that these are intended to be written by service owners and describe things like circuit breakers and timeouts and so on. So Istio does expect application developers to be interacting with the Istio or the Cube control command line interface to be modifying destination rules. So the next example we're going to go through is a circuit breaker, and circuit breaking is a pattern for creating resilient microservices applications. It's typically implemented as if a consecutive number of errors, if you get a consecutive number of errors that cross a certain threshold to a certain host, the circuit would flip, and any subsequent request to this host would result in a failure. until there is a timeout that is set and until the timeout is met. And once the timeout is exceeded, the circuit closes, a limited number of requests start flowing to the host again until and unless the host is unable to process these requests. If it is able to process them, everything's fine. If not, the circuit will open again. So this is so as to not overwhelm the host. You can think of it as being similar to how a circuit breaker works in electrical systems. So I have a simple example here from the Istio world. As I said, it's declarative syntax in the form of YAML. I have defined a destination rule for this host called foo, and I've created the traffic policy that tells me what is the maximum number of HTTP and TCP connections, and it also defines the behavior of the circuit breaker when it trips. And the part to note here is that this can be applied through a kube control apply-f file name. And at any point of time later, if you want to change the behavior of your circuit breaker, you would just change certain parameters and apply this destination rule again without touching any of your application code itself. So it is completely abstracted away from the application developers, and it is left up to the operators to configure and manage the mesh.
In Spring Cloud, we integrated a popular circuit breaker library in Hystrix from Netflix, and the mechanism for interacting with the circuit is via Java code, right? This is basically a default example here. You extend Hystrix command, and you put your application code in the run method. And it can really be doing anything, right? Generally, you're protecting some sort of network call, right? So that you can protect the cascading failure of that network call from whatever service you're calling. The interesting thing here is the fallback, right? So if an exception occurs, whatever that exception may be, whether it was network or what else, you can return a fallback. In this case, it's just static data, but it could be looked up from some secondary source. It doesn't have to be static, it can be dynamic. There's also a annotation model that does almost the identical thing, just provides something that's pretty familiar to Spring users and annotations that Spring is famous for. The configuration happens in normal Spring Boot configuration, so similar to how Istio works. If you're using some dynamic configuration like config server, you could change these properties on the fly and reload your configuration and things would change. So an interesting problem occurs if you deploy a Hystrix circuit and you configure an Istio circuit and you're running at the same time, right? That could lead to some unintended behavior, some pretty interesting behavior. So if that's the case and you are moving an application that has Spring Cloud libraries in it, you could, this last line, for example, just turns off the circuit for that particular circuit that is defined by find user, yes. But the rest of the Hystrix library will continue to function, so fallbacks will continue to perform just as you had before.
Right. So our next example is retries. So retries help in masking network irregularities from clients of microservices applications by simply retrying a request. In the case of Istio, again, it's defined as a virtual service, and as I said, it's declarative. This is a YAML for one of my services, foo, and I've just specified the number of retries there. And at any point of time, if I want to change the number of retries, or there are other configurable parameters such as per retry timeouts and so on, I can change those through this virtual service and do a kube control apply, and it would change the config for this host, and I wouldn't have to touch anything in the application itself or redeploy or do anything.
So in Spring, there are a couple of mechanisms that we have used for retries. The one that we've adopted in Spring Cloud is Spring Retry. Here's a very, very simple example showing the annotation model. But Spring Retry allows both an annotation or a template model, and You can also keep state across retries if you have a situation where you have to know exactly what happened on the previous retry. This allows for it. It also allows for flexible retry policies. Here you're seeing exceptions. We have it in other Spring Cloud libraries where retry is retrying based on certain HTTP codes, for example, not just an exception. And then we also have a very flexible back-off policy, such as the exponential back-off policy, so that you don't, hammer your service that is struggling since you're retrying, right? You can eliminate the thundering herd problem. But the other option we have is if you're using WebFlux, the new Spring 5 web framework, then Project Reactor has some very, very similar retry capabilities. So another interesting problem with distributed systems is, problems happen and you need to figure out where. But instead of a single monolith, you have a big tree or graph of services. Anyone ever had problems with microservices? Anybody? Yeah. So tracing is a diagnostic tool that allows you to see where latency is occurring in your applications. So the way it works is when a request comes into your system, a trace ID is created, and each step is called a span, and there's information associated with all this data. But to be able to analyze that data has to flow through the entire request, and so that information has to cross network and thread boundaries. Now, Istio is instrumented such that when your calls through Envoy happen, they will be automatically instrumented, but through your application, you still need to propagate those headers. And so that's what Spring Cloud Sleuth does. It instruments many aspects of Spring automatically, so you don't really have to worry about that, and it just kind of happens. The other thing that it does is it adds that tracing data to logs. If you have some logging system that is slurping up logs, you can correlate your traces that you might find in a system like Zipkin or Jaeger and correlate them to your logs.
Right, so I have a dashboard here from Istio, and you can see my application calls several other microservices, and you can see just the span of network calls here and how much time it took for each network call. And as Spencer mentioned, that Envoy can automatically get the span data, but it has to have the hints from the applications as to how do you correlate all of the span data. And it does so through the application itself has to implement the code to propagate the incoming headers to outgoing responses. So basically here you can see that my Java application here is using this code to just propagate the headers. So my Envoy can actually tie up the spans together.
So another interesting aspect of applications is security, right? So Istio provides some interesting security aspects, what services can talk to who, but it also secures communication between those services with mutual TLS. But there are application level concerns in security that are specific to your application, and Spring Security handles that very well. I know there are a number of Spring Security talks today. There was one earlier that you should definitely go and check out. But whatever is, Spring is very, in fact, do I see an author here? Yeah, there's Rob. Thought so. Very flexible and allows you to deal with your application security in a manner that might not map one-to-one to an individual service. So, I guess this is the slide we've all been waiting for, right? When would you use one or the other? And like all really, really interesting questions, really the answer is it depends. If the platform provides it, right? If you're on a platform that provides Istio, I would think that, maybe the 80-20 rule that those cases are covered, then you should use what is provided by the platform. There are some things, we kind of mentioned some of them as we went along, where, and generally they're specific to an application, that those things should be dealt with by an application. Things like fallbacks, the tracing propagation, and application-specific security.
Yeah, so Istio or service mesh architectures work better for polyglot environments than than language-specific libraries in some cases, because it supports polyglot services by way of how it's architected. And if you're on K8s, then yes, Istio might be a good choice. It also depends on what your risk propensity is, right? So Istio GA'd in July 2018, so it's not even at this point 4 months old. So it is a new technology platforms and comes with its, it's still maturing. Spring Cloud, on the other hand, has been around for 4 years.
Yeah, and the libraries that they incorporate have been around for even longer than that, so very mature.
And it also, I think the other thing to look out for is performance. The Istio community is still actively working on ironing out performance issues, and they're still actually benchmarking and trying to figure out, what is the impact of having Mixer in the data bath for every request and response, what's the impact on control plane components and so on, and you have to be more cognizant of your performance expectations and definitely try and test performance for your use cases. For instance, in the Cloud Foundry world, we are extensively testing the control plane because our integration depends on that, and we also are extensively testing the integration of the control plane itself. So you have to be cognizant of your use cases and make sure that you can test for performance with this new framework.
Yeah, and like I said, if your application has needs that aren't met by what the framework provides, there's an escape hatch, right? You simply don't have to configure whatever it is that doesn't quite work, and then you could fall back to the library-based approach. So before we get to questions, there are a number of talks that you might be interested that might provide some more information on both of these subjects. The routing team, or network team?
It's actually a combination.
Combination of both of them. Yeah, and shortly after this talk, we'll be talking about integration between Istio and Cloud Foundry. Myself and Mauricio Salatino, sitting right here up front, we will be talking about Spring Cloud on Kubernetes, on PKS, that was mentioned by Dave Sire this morning. Thanks, Dave. Also, Ray Tsang will be talking about Istio on Kubernetes also later this week. With that, we will open it up for some questions. Here in the front.
Yeah, so I noticed that with Hystrix, the configuration for things like circuit breakers is all done entirely on the client side. And it sounded like you were saying that for Istio, it's a destination tool and it's owned by the service owner. I can foresee a lot of cases where the client is going to have the best understanding of what their needs are as far as circuit breakers. Can you configure that on both sides in Istio?
So we are actually still debating that on our end. I'm not super clear about it, but yeah, I mean, I can get back to you on that. We had the same discussion on one of our Slack channels pretty recently, and we were like, yeah, can we do this both sides? And I don't know if there is a direction from the Istio community on it, but yeah, I think it's still open.
I did have one other question I'd like to ask.
Yeah, sure.
With the tracing, I think I saw the Istio with the proxies, they are HTTP or TCP. Is there any model, I know it's relatively new, are there any use cases for running the proxy in the same pod or with the database in the sense that you can front the database, and if so, can the tracing cross TCP boundaries that way?
I haven't seen that yet, but yeah, sorry. So I think your question was that the example I had, and from what you've seen, tracing is across HTTP boundaries, but is there a way to enable tracing across TCP boundaries?
Yeah, so it's not just for applications, so you can front the database with the Envoy proxy also.
Right. I haven't seen an implementation of it, or heard of it yet. I am not sure if anyone has tried it out. So I think you can definitely put that out in the Istio community, and they might be able to answer it better.
Right here.
Istio, from what I understood, sounds more like a platform
Yeah, that's what this other talk is directly talking about, yeah.
So your question was that do you consider Pivotal Cloud Foundry as a platform?
The,
Right. Yeah, so I think the other talk will cover it in more detail, but in general, I think we are thinking about those user experience questions quite actively, and we are thinking about like how would the experience, if Istio is a part of Cloud Foundry, how would the experience look like for application developers and operators, and would it be completely transparent, and would they prefer to have a completely transparent experience? As an application developer, you don't care whether Cloud Foundry is using Istio or something else in the background, right? You care about, can I do weighted routing, and can I do canary releases, can I do A/B testing, and so on. And I think we are still actively thinking about what the user experience should look like for application developers and operators. But the other talk will go into more details on it.
front. So he's asking about overhead costs, and Hystrix is Java library overhead, so method calls. Sure, there is some overhead. It's a library. As far as the Istio overhead.
Yeah, so I think in the case of Istio, they are still trying to figure out what the performance implications are. Envoy itself has been tested and has been run at scale. So I think the performance implications for Envoy are better understood. But the control plane components are the ones which are still newer and being tested in production now, and by early adopters and early customers, right? And for instance, for Mixer, for sure, there is a performance hit in terms of, every request makes two requests to Mixer, right? Every request that goes through an Envoy is actually going through Mixer twice. So if you look at my traces, you will see that Mixer is being called twice in each of these. And there is a performance hit because of Mixer. So I think they say that if you have Mixer in the call path, then it takes 20% more CPU, and so there's definitely a performance implication to that, but they're still trying to figure out the performance and scaling guides in the Istio community. But Envoy itself has been tested, and it's battle tested, and it's pretty solid.
I don't know that we have a good comparison of one versus the other. So, there's back in the back here. Compared with what? Linkerd. I don't know that you could really compare Istio and Linkerd. You could probably compare Envoy and Linkerd. In fact, I think you can install Linkerd as the proxy. I think there are examples for Istio. So yeah, that's really the comparison there. Yeah, I'm not sure.
I've also seen Nginx being used as the proxy in Istio Service Mesh. Nginx has some papers out there. So I think you have to compare Linkerd to Envoy.
Yeah, and Linkerd is a Java application, right? Envoy is C++. So yes. So question, you can use Istio for the circuit breaking and Spring for fallback, is that what? Yeah. If you're using Hystrix, you can just disable the circuit and it will just should just work. Or you could just deal with whatever the error is you get back, you know, if it's a 500 error, and just deal with it in your code directly. So, any others? Thanks.
Thank you.